to our video. So today, we are going to analyze our data with the use of 4-factorial design. Two or more factors with different values, levels, and also, in this experiment, we will see that it uses different factors to create a multiple possible combinations. To know how does every factor affect the tutorial. So let's start our tutorial.
Good day everyone. Today we're going to explore the MiniTab. In this video, you are going to learn the basic components of MiniTab, basic steps you need to do in MiniTab. We have here a experiment, a paper helicopter released into the air with measuring from the ground to the abyss in 2 meters. We only use one type of paper, which is the bond paper, and we have here the data. We have here the rotor length of our paper helicopter. We have 2 because we need high and the low. The rotor length, we have 4.2 and 5.2 in centimeter. Then in leg length, we have 4.8 and 8.3 in centimeter also. Then leg width is 2 and 3 in centimeter. Then the paper clip, we have on and off, which is the on indicates that it is with the attachment of paper clip, and off is without the attachment of paper clip. That is the data we are going to use right now. So the first thing to do is to click the MiniTab. Open your MiniTab. Then look for the statistic. You have here the stat. Click the stat. Choose the OE. Choose factorial. Then create factorial design. Next is click the general full factorial design. Then your number of factors should equal to 4 since our factor is 4 in this video. Why 4? It is because we have the rotor length, the leg length, the leg width, and lastly is the paper clip. Then click for designs. Then for number of levels, we have 2 because we have two rotor length, we have 2 leg length, we have 2 leg width, and the paper clip we have on and off. That's 2. So 2. Then for the name, first for the letter A, we have the rotor length. Then the leg length, the leg width, and the paper clip. Number of replicates should equal to 1 since we're using 1 replicates. But if you want to, then you can click 2. But in here, in our sample, we need to choose 1 replicant. Then factors, click for factors. Then we have the in numeric. Of course, our rotor length is in numeric. We have, as I said earlier, we have 4.2 for our first rotor length, and the other one is 5.2. Then for the leg length, we have 4.8 and 8.3. For our leg width, we have 2 and 3. And for our paper clip, which is in text mode, we have the off, and the on. Click OK, and OK. Then this one should appear on your set, guys.
So now we have our results. We have the design summary. You see we have those numbers, digits. Now we are going to do an experiment based on the design summary that we have gathered. Now, next on the experiment, we have all this data that we have collected. Now we are going to put this in the MiniTab. We are going to name this column as I think flight time. We're going to name this as flight time. And then we're going to copy paste all of this data into the MiniTab. And select this, all this, copy, and then paste it to the flight time response column. Now next we are going to analyze the data. We're going to stats, DOE, factorials, and then analyze factorial design. As you can see, there's a flight time, the name of the column, and then select that, and then we're going to terms. So we only need these first four variables, and then select the fifth one, and then place it to the other side until the only left is those four. Then okay, same, that's okay. Next, let's go to graph. And then select the 4-in-1, and then select the residual versus variance variables. Select the variables, the leg length, the leg width, and then the rotor length. And then okay. And then let's results. That's okay. And then next is the storage. Then we're going to select fits and residuals. So the fits is will give us the result, which is the predicted values, and as for the residuals, it will give us the difference between our predicted values compared to our actual values that we have gathered. And then just press OK, then OK again, then it will the results will pop up, as you can see.
So now we have the analysis of our data. Is the first thing, the analysis that First we have is the factor information. So you can see the information to all of our factors from router length to the paper clip. So this is their factors, and there are two levels each of the factors. So you can also see here the ANOVA analysis of our data. So you can see here our p values, f values. Also, you can get the model summary, the coefficients, and also the regression equation. As you can see, there. And also the fits and the diagnostics for usual observation. And also, we can get the Pareto chart of our standardized effects. So as you can see, the chart shows that the factor C, or the leg width, has the greater effect to our flight time. Yes, to our flight time. So the factor C, it has the greater effect. That's what it says. So also in the right side, we have four different plots, because we in our process we take it as 4 in 1, so can get it this way. So here the first plot is we have the normal probability plot. So we get that it is a normality on how the residual is distributed to the table. So as you can see, it is most of the data are near or close to the line. So that means it is normally distributed. So that means it's not biased data. Also is we have a versus fits plot. So between residuals and fitted value, which is our actual data, and residuals, the predicted values that we get. So as you can see, it is also scattered. So you can see there is no pattern between each of the dots. So means also the data is not biased or being played. Here we can have a histogram, which as you can see it is skewed to the left. I mean right, skewed to the left rather. So that is how it is. And we have also the versus order residuals versus observation order right there. And also last we have the three plots here: the residual versus leg length, residuals versus leg width, residuals versus rotor length. Same as the other right there. It also tells us that our data collected, or the analysis shows that our data has effect, or has significant effect to our flight time.
So the next step that we're gonna do is, now we're gonna know the optimal level of our result. So let's go to stat, click DOE, then factorial, then click factorial plot. Then we select the 4 factors, then let's go to option, then okay, then select all terms graph. So we're going to show the main effect and interaction plot. So all of that are checked. Then in flight times, okay na, it's all set. Then let's click OK. This is now the result. We have the main effect plot, then we have the result of rotor length, which come first, followed by the leg length, then paper clipped. That's the order on how these factors affect our flight time. So here we have the interaction plot. So this is where we can see the interaction between the two factors that correlates the that what do you call this, correlates to our response, which is the flight time. So here the leg width, then paper clip. So that is the interaction. So that is how we're going to use the MiniTab analyzing your data using the factorial design. Thank you.